Hello everybody. In this presentation, I am going to give a brief idea about the NetMosaics system. NetMosaics is a patented real-time click fraud detection and prevention system. The current product is a result of many years of comprehensive research at our data mining laboratory in the University of Louisville. The project is funded through NSF and KSTC grants. Click fraud, as we know it, is the process of generating fraudulent clicks, either by software or by humans. It has now become the single biggest threat to the growth of the pay-per-click advertising model. While Google dominates 60% of the pay-per-click advertising industry, Yahoo and Bing have approximately 20% and 10% market shares in the PPC advertising, respectively. These search engine providers usually claim click fraud as less than 10% of the total traffic. But most academics and third-party consultants who study online advertising estimate at least 25% to 35% of clicks in pay-per-click online advertising is not authentic. Both search engine providers and third-party consultants offer solutions for click fraud. Almost all of them are based on rules developed by experts in the area of click fraud detection. These rules are kept as business secrets, and as a result, there is no universally accepted solution for click fraud. In these existing solutions, clicks are classified as either valid or invalid. We have seen that this classification is not always easy, and most of the solutions have to force clicks to join one of these groups. We can see this scenario in the next few slides. Clicks are associated with a lot of information. For example, the IP address, country, referrer, browser properties, etc. Since we want to classify clicks as valid or invalid, let us visualize clicks in a higher dimensional space. So in this web page, we have 3 clicks initially, and more clicks, and some more clicks. Out of these clicks, there may be few clicks that can be identified as either valid or invalid clicks. In this figure, such valid clicks are marked in red dots, while invalid clicks are marked as crosses in black. We can draw 2 classifier boundaries to identify these 2 groups. But what do we do with what is left behind? Unfortunately, most of the clicks land in this fuzzy region. As I told you before, there is no unique solution to handle this region, or at least impossible to develop a rule-based system that answers why a click has landed in that region. This is the main reason for the ongoing battle between different solution providers. As you can see, this will last forever, at least until we all come to a common solution one day. As that day is not very close to us, we have developed a unique solution that does not depend on rules. All we need is very few label clicks. For example, if we know that after clicking on an ad, if somebody submits a form, or if somebody buys a product or service, then it is a genuine click. This is that we all can agree. On the other hand, if we can identify clicks generated by a software robot or clicks that are duplicates, then these are examples for fraudulent clicks. Based on these limited data, we can build a classifier system using a technique called support vector machines. There are many advantages for using support vector machines or SVMs, and I would like to name a few. First, it requires only limited labeled data. We do not need human experts to sit and go through every single click recorded in a web page or in a click campaign. Second, our model generates rules for us, but not the vice versa. We call this model as semi-supervised learning. Since the rules are machine generated or human independent, we do not expect arguments such as who knows better. Because in these existing systems, we can always question why and how a certain rule has identified as a valid or invalid, since these rules are developed by humans. Third advantage, or more importantly, our model changes dynamically. For example, fraudsters come up with different types of attacks to go undetected. For each such attack, click fraud experts have to design a new rule. This is a tedious and a never-ending process. But with SVM, we can leave it alone to adjust to new situations. We ran a couple of experiments with click data that we have collected. Experiments are conducted with the SVM model and with the rule-based model that we have developed. We were able to match the results of both systems, which convinced us that SVM is able to generate the same results and we can replace the rule-based with it. NetMosaics has few other unique characteristics which are worth mentioning here. We do not evaluate clicks as valid or invalid. Instead, we give them a score between 0 and 1, where 0 stands for genuine click and 1 stands for fraudulent click. NetMosaics also have blacklists, which are used to prevent fraudulent traffic instantaneously. Search engine solutions are based on server-side logs, and other third-party solutions are based on client-side logs. Unlike any of these systems, we use both server-side and client-side data to generate our conclusions. Our architecture was designed considering the scalability as a fact, and we have separated the data collection and the data processing systems. In this slide, we show some results from an actual ad campaign that we ran with a large global search engine company which provides click fraud protection as well as search engine capabilities. In the first campaign, we lost almost $12,000 for fraudulent traffic, and in the second campaign, we lost around $13,000 for fraudulent traffic. These figures were never identified or investigated by the said company. Nowadays, fraudsters commit click fraud with the use of software bots. NetMosaics is immune to such attacks, and this example shows how it identified an attack from a Bahama bot. For example, let us assume that the user's device is infected with the Bahama bot. Then if the user searches for Dell laptops in Google and clicks on any of the search results, he or she will be taken to the requested web page. But through numerous referral sites. Bahama bot converts organic search results to pay-per-click results. This process is not suspicious to the user as the user finally gets the requested web page. If we plot the time versus traffic for the day, we can identify the regions where the traffic density is high. Using the baseline module of the NetMosaics system, we can easily identify these regions, which are here marked in red. With that, I would like to conclude the presentation, and if you have comments or suggestions, please feel free to ask. Thank you.